Well, hello. Hi, everybody. My name is Josh. I'm joined by I. You and I were you and I were talking, and you said, "Hey, you should watch this video." And I got 5 minutes into it before I realized I had actually watched the video, and I was like, "Well, this is dumb of me. I should just like it's much better to have you on the show than because I've already seen it and it was good, and I should have gotten you on the show before. So I'm so happy you're here, Gregory. Mr. Green, how do you introduce yourself? Do it so that I don't butcher it, please.
Yeah. Hi. And my name is Gregory Green. Thank you so much, Josh, for
Oh,
the
cheers.
invite. I'm part of the Tanzu pre-sales team. I focus on our data products, but I'm a developer at heart. But really, I enjoy telling the story of how our data products can help with various application data and messaging use cases. So yeah, that's pretty much me in a nutshell.
So you're doing the most important thing in software today, is what you're trying to say. I understand. That's fine. You're a little modest. Data is the gold on which all this AI stuff is, is sort of predicated, isn't it? I mean, uh, without context, it's all just a show and a toy, you know? Um,
I do think so. I think like you really can have a useful application that uses data in some way, shape, or form. Like you could have like an emoji app or something like that, but you really need data.
Data is important. Yeah, it feels very important. And I suppose that's always been true. Uh, it's always been true that data is important, but it's just sort of now that we have these AI models and these things that can do such amazing tricks with that data. Oh, you know, feels more important than ever. Um, okay, so you and I work at Tanzu. Tanzu was a division of VMware. VMware got acquired by Broadcom, so now you and I are happy members of the big old Broadcom family. But we're still part of Tanzu, and that's where Spring is sat, and several other things I think people might be familiar with. Not the least of which is RabbitMQ, right? RabbitMQ is the it's one of those. It's just one of those things where it's just always been this sort of Swiss Army knife broker, messaging broker. But even that, I think I did a bad job there, and I'm hoping you can uh, correct me in a little bit and kind of get me back on the right framing here, because it's not just a broker anymore. It's not just a message queue, is it? It's a distributed log, and then we got RabbitMQ. We've got Valkey. What's Valkey?
Yeah,
What was it
Valky.
before?
Yeah, Valky is relatively new. It's an in-memory cache. It's a fork of Redis. So Redis changed their licensing model with I think it was version 7.4 or something like that,
Yeah.
where basically people that supported the open source version of Redis weren't able to support it. So as a reaction of that, the community forked Redis, and now it's Valky, and a lot of excitement happening in that community, a lot of features, but it's an in-memory caching solution.
Right, right. I've used Valkey. I've used the cache formerly known as Redis before. Obviously useful. It's got some very obvious use cases there. But then there's the 800-pound gorilla of data, which is I think has infinitely more use cases. Gemfire. What's like? I want to hear. You've got a better perspective on it. Can you define what is Gemfire?
Well, first of all, Josh, I gotta say that I am in love with Gemfire.
Yeah.
Gemfire is one of the main reasons why I have my job today, and I'm able to talk to awesome people like yourself,
Oh, thank you.
because I knew Gemfire. But Gemfire is classified as an in-memory data grid. The closest thing you can think of is like NoSQL databases. It's a
Yeah.
shared nothing architecture. It's distributed. You can distribute it across multiple data centers, to multiple availability zones, but it focuses on in memory. So it's in memory, so it's really fast. But one thing that's unique about it is it supports strong consistency, meaning
Right.
that even if you have that data distributed across multiple availability zones, so on and so forth, when the applications write the data, they will read the data that was last written. And there's some other cool stuff that's included into it. Also, it's a first-class citizen for Spring applications, so it unlocks a lot of the not only the caching use cases, but for Spring applications, but also it could
Right.
distributed compute. Like for example, think about like why you use a store procedure, right? You want to move your data logic to the database. You could do
Right.
the same thing with Gemfire, right? And you can bring cool libraries with you, package it all in an Uber jar, push it to the server, distributed server, and have these functions that operate really, really fast. It's really, really popular in a lot of financial sectors, but really any use case where you need not only speed but scalability.
Wow. Uh, the thing I first heard about it, it used to be was it Smalltalk? I think it was Smalltalk. There's Jim Stone, and then the VMware we had VMware acquired it. Is I think it was acquired right before I joined. So, but it was this. It had been this popular Java. I mean, obviously they moved to Java some decades ago, like 20, 30 years ago, and it had been a popular, like, the best kept secret in the data space. Like, it was, people who knew about it knew it was awesome. People who didn't know, when they had that use case, it's the first and best solution that came up. And I'm not going to name names or anything, but there are some other vendors that have things that they imagine fit in the same category as Gemfire. But those vendors' customers would come to us asking, like, can we? Is there some way to do? They wanted us to take features out of Gemfire and somehow front these other vendors' solutions with that. So one of them was the WAN gateway. The WAN gateway in Gemfire is amazing, right? The idea that I can have distribution. You mentioned availability zones, but I think that it doesn't. Just think global scale. I want to write something in Singapore and see it in France milliseconds later, right? Linearly.
Yeah,
Um,
y-
that's
yeah,
Gemfire.
yeah, absolutely. Yeah, absolutely. So it supports different use cases based on where you need consistency. So, for example, when I mention availability zones, that's basically, let's think about like a cluster which maintains strong consistency across different sites,
Right.
across different data centers. But let's suppose like all your data centers, maybe they're on the East Coast, right? And maybe the latency between those data centers is really fast. Maybe it's
Right.
like,
Speed of light.
milliseconds. Yeah, milliseconds. But then you may have use cases where you need to have either disaster recovery or another version of the applications that are in data centers, maybe on the East Coast and the West Coast, or even across continents, right?
Yeah.
So again, because Gemfire is really built on speed, when your applications are accessing data, you want that data access to be as close as possible, but you can also replicate asynchronous to another location. So and they'll basically eventual consistency across wide area networks, different geos, right? So yeah, that's a very popular use case
Right.
for Gemfire, not only for like disaster recovery, but active. So
Oh,
our friend is Deshaun. He says this all the time, which he cracks
yeah.
me up when he says that he has a couple of rules in his house, but one of them is that his kids will never
Never.
deploy active passive, right?
Yep. Never.
So yeah, so that's why people who are passionate about active, like Deshaun, they love Gemfire because when you're writing on any side of the globe in the Gemfire cluster,
Right.
it will do things like resolve conflicts. So it has some internal ways to resolve it based on like preferring certain clusters, and it does conflict resolution. So if it gets events out of order, it will make sure
Right.
that it ignores stale data and things like that. And another thing that people love about Gemfire is it's extremely customizable. So if you don't like the default conflict resolution logic, guess what? You can just write a little bit of Java code to implement your own conflict resolution. So it's really powerful. And it supports things like events, There's something called continuous
Continuous
query.
query. Yes.
Yeah. So like typically, like if you wanted to detect like a change, like a change data capture, right? You would probably need to query the database to see are there any changes, any other changes, and there's a lot of overhead to continuing polling the system of record to detect any changes. But with Gemfire, you could basically have a query statement. You say, hey, Gemfire, take this query statement, and anytime there's any sort of change with these records, whether it's an insert, update, or delete, um, let me know about it. Send me the changes. So Gemfire will
Right.
push those changes. Right. So that's another popular use case
That's
for
and that's one of those things where um as the facts, because who knows, instead of constantly querying it, instead of me constantly querying my SQL database, asking it for the delta, and of course there's going to be maybe a second or half a second or whatever delta between each poll. As the facts on the ground change, let me know. So I can. It's much more efficient for the clients. They maintain one connection instead of constantly opening new ones and polling, and they get the updates almost instantaneously. So in that way, you get like a. You can also use it like pub sub, right? I can
Mhm.
put a thing in there that matches a continuous query that somebody else is listening for. They get notified instantaneously. So it's much more efficient.
Yep, yep. And Gemfire also has like just basic pub sub. There's something called cache listener. So you could either register interest by a query, but you could say anytime anything changed with this data set, just let me know. I could also say if I can match patterns on the keys. So if the keys are strings, I could say, if these keys change, let me know. A
Right.
lot of different things that you could do with Gemfire.
Gemfire is good. Are we so Gemfire nowadays, the other thing I think maybe we established this already, but you can use Gemfire to hold just enormous amounts of data, right? Because it's a RAM cloud that has disk persistent. But
Yeah, absolutely. Yeah. It's a shared nothing architecture. So essentially, you can add the capacity to add more and more data by just adding more servers, right? And Gemfire on the server side is based on the JVM. And nowadays, with the newer versions of the JDK, like using the generational garbage collector, you could really have really large heap size. And then, because traditionally, you have to worry about garbage collection and the overhead of garbage collection, like
right,
pauses, right? But
right.
now you have these pauseless garbage collectors. So we've got, for example, we got some customers that are running over a terabyte of heap for a single a Gemfire server. So they'll run
Wow.
like hundreds of Gemfire servers, have everything all in memory. Then they're using the distributed compute and the functions and things like that. So they get high availability, low latency, all on a single solution with strong consistency. And that's, again,
Yeah.
like they wouldn't consider other solutions for, especially when you're dealing when I go back to like financial sector, you're dealing with money. So
Right.
there's an implication when I read the value of the dollar value of something, whether it's stale data or not. Right? It's
Right.
critical that it can't be stale.
Right. And it's got to be, so when you say strong consistency, you mean it's written in a quorum or is it written to a disk?
Well, it's an in-memory first. But that's a great question because Gemfire does support persistence.
Right.
So, but it can write and read to the memory first. You can configure Gemfire to have X number of copies. So you can say, hey, I want 2 copies of the data. Whenever I do a write, it's going to synchronously make sure that it's in not only the primary but in secondary copies. I can make sure that those copies are again in different availability zones, and I can persist it to disk. I can persist it to disk asynchronously. That's the default behavior, or I can persist it synchronously. So again, you could have multiple copies in
Wow.
memory and on disk. So and in that case, you really don't need a database. So
No.
Gemfire, it can be used as a system of record because everything that you would need for a system of record, like
Yeah.
backup and recovery and things like that, multi data center failover. They're all built in natively into Gemfire.
Now, Gemfire, how do I ask questions of it? I know I can write a processor to kind of process the data in Java code, but that feels a little inefficient. Is there a query language or
Yes,
some way
yep,
to
yep.
work with the data?
Yep. It's various ways that you can query the data. So access the data. So Gemfire at its core is a key value pair, right? So
Right,
very similar to Redis, right, or a val key, right? You have the key. You can. That's the fastest way to get out data,
right,
but also it supports what's called OQL. It is basically SQL.
right,
And instead of like in SQL, you just specify the table name. In Gemfire, you just have to put a slash before the in Gemfire, the table names are called regions, but
right.
Josh is pretty. It's just SQL. It's
Oh yeah,
pretty much just SQL. And there's a couple other ways. It supports a full text search.
right.
So Gemfire has it bundles with another open source popular open source project, Apache Lucene. Are you
Oh
familiar with
wow.
Apache Lucene?
Yeah, is that new? Is the integration with Gemfire new?
No,
Really?
that's been
How
in
about
there
Spring?
for a long time, Josh.
That's
Um,
cool.
So yeah, so basically you have these Lucene indexes, again, all distributed, all in memory. So you can do full text search. All of the query predicates and or logic that you can support with
Right.
Lucene, you can do that with Gemfire. And then one last thing is building on top of Apache Lucene, the product teams expose, they have a way for you to use Gemfire as a vector database. So you could do semantic based searches all in memory for
Lightning
in
fast.
Gemfire.
So good. So good. Um, and the OQL, one of the things I loved about it is you can do method calls in the, you can on the object that's stored there, you can call if it's a Java object, you can dereference a method and invoke it in the query. So
Yep.
it's like select all from forward slash products where p dot calculated price or whatever parenthesis is greater than whatever, something like that. It's just, I mean, just such a good database. Um, so okay, I didn't realize there's a full text search mechanism in there. That's like really Lucene. I didn't. I mean, all these years I've been using it, I had no idea. That's on me. That's embarrassing. So I had no idea. I didn't even think to look because it does everything else I wanted for. I've even I could even imagine dumping it into like an Elasticsearch, using it as a store of record, and then keeping a spare because it's so fast. I could store everything there, and then right behind to something like a Elasticsearch for my full text search use cases. But it turns out I don't even need that. It looks like that's because Elasticsearch is based on Lucene.
Nope, you don't need it. But I will say that another thing that I didn't touch on, which
Yeah.
since we're talking about Gemfire, another very popular thing is let's suppose if you're not using Gemfire as a system of record,
Okay.
but you
Imagine.
want to make sure. Let's suppose you're using like mainframe or like some other relational database as your system of record, right? For whatever reason, right?
Right.
But you want to
Bad
keep
life
that data
decisions.
yeah, you bad life decisions, yes.
Yeah.
um but you want to keep that data you want to access that data in Gemfire, right? Because it's blazing fast.
Right.
What you could do is there are hooks in Gemfire, and things like there's different patterns or like a write through pattern. Let's
Right.
suppose like again so what you do is, again, Gemfire is not a system of record, but you do all your write operations in Gemfire, and then you have code server side in Gemfire that will make sure that it writes that data to another system. If
Right.
you need that data to be consistent, meaning that if it fails to save in some relational database, don't save it in Gemfire. You can absolutely do it, and you can
What is that called?
also it's basically the write through pattern.
Right through pattern.
Um,
Yep.
yeah, and Gemfire has like there on the server side. There's something called a cache writer.
Right.
So that you attach a cache writer to the Gemfire datasets, which is called a region. So every time you do a put operation, it's going to call the cache writer, and it's cache write is going to do what it needs to do. If it can't do what it needs to do, meaning write to some other system, it's going to throw an exception. It's going to roll back that whole write operation. That's one way, and that supports synchronization. The other way is it's the asynchronous way to do it. So basically,
Right.
Gemfire has like internal. It's called async event listener. So
Right.
Gemfire has like queues. So when you write to an entity, it's gonna batch the write operations. It's gonna pass it to this asynchronous listener. This asynchronous listener can asynchronously send to that data to that external system, and if it can't save it for some reason because the database is down, there's retry logic built into Gemfire. So anyway, just whole lots of ways, patterns like that. There's a read through patterns to keep Gemfire in sync with other systems.
Wow. And that's right behind, right? Like
Yep, that's right
yeah.
behind.
So I mean, both are really easy to do, and so this becomes your data hub because you just hang these little integrations off the side of your Gemfire cluster, and off you go, right?
Yep.
That's amazing. I'm a huge fan. Huge fan. What are do we have any publicly available uses that we can talk about where nobody would have to like 007, you could tell us, but then you'd have to kill us.
Yes, there is a public webinar that was done during the. Remember when we just had Spring One, Spring One
Yeah.
talks.
Right.
So there was a major credit card company that talked about how they're using Gemfire for every single credit card transaction.
So cool.
Yes,
that's
and
so cool.
they do their fraud detection using Gemfire. Like
Right, that makes sense.
yeah,
Infinite, like, oh, that's because you can do
yeah,
complex event processing, right? You can say when this is true and that is true, therefore this is true, right?
yep,
Oh, that's
yep,
so
yep,
cool.
yep. And it's just Java code at the end of the day. Bring your own
Right.
Java code, do whatever you want. It's all in memory, right?
But
So
the point is the Java code only gets run when things are true because of continuous query. That's a
that's
wow.
one option. Yeah. But remember the other thing is like functions, right? So it's just like calling a store
Right.
procedure. You could do anything.
Yeah. And then when you're running that stored procedure, again, like you said, you're running the business logic visits the data instead of the data visiting. Like most people, I think, are used to the idea. You can do this with Gemfire. For people who don't know, you can write code that sits on a client, and you can pull down the data and process the data, and then write it back to the server. But that's very inefficient, right? Like it's, instead of you pulling the data to your client, to your code, you push the code to the data, and it can run, like you said earlier, like a stored procedure, light speed, right? Just many
Yeah,
fold
yeah.
faster.
Yeah, and I heard other people talk to it, and it's like data has gravity, right? So when you're
Yeah.
talking about like extremely large amounts of data, right? Like hundreds of terabytes, even petabytes, right? You don't want to be pulling all the large data sets from servers to
No.
client applications, especially when you have extremely strict response times requirements, right? So
Right.
if you can move that logic as close to the data as possible, that's what you want to do.
I'm a fan. I'm a big fan. And I know a lot of people are using Gemfire, and it's just one of those things where it's once you've got Gemfire, it's very hard, I found, to justify bringing in. I mean, it does so many different things. I just found out in this very live stream that it does full text search. Like, and I've been using it for 17 years now. Um, That's cool. That is so cool. Okay, that's not even what we put on the. I didn't realize we were going to talk about that. That's so good. That is so good. Where do people learn more about Gemfire? Just before we move on, is there
Oh
a
yes,
landing
yeah.
page or something?
So yes, gemfire.dev, right? So you could just go there. It has a whole bunch of tutorials and things like that. You can get started. Yeah, lots
It's
of example codes for
beautiful.
Java and Spring, and that's really the easiest way for you to get started.
What is happening? My life has gotten. It's not even Christmas is in 5 months. It's not even 4 months. Can't believe this. Look at this website. I've never even seen this before. It's beautimous. Look at that. Java and Spring.NET C++. Oh, that's another thing. It's got, so you can store data like it by default. If you're using like Spring Cloud for Spring Data Gemfire, it'll do serialization, and you could probably get it to do Java serialization, but it has its own persistence format too. That's really efficient, right? This binary format. And so you could store data in a Java program and then read it from a C++ program. That's the other thing that's, I think, maybe not
Yeah,
obvious to people.
yeah, absolutely. C++, also .NET,
Yeah.
.NET, the legacy .NET and the newer .NET Core. There's
Yeah.
libraries for that. Absolutely.
So good.
There's a whole ecosystem of connectors.
Yeah.
So yeah, absolutely.
And vector store, that part I knew about. That's cool. Like the, yet another I never, this one's not that impressive because like there's 1,000 every, because we have in Spring AI, I'm sure you know this, I'm just talking to the audience here. In Spring AI, we have the simple vector store, which is literally an in-memory Java implementation of a vector store capability. It's 300 lines of Java code or something like that, right? It's some simple math basically to create a vector store. And so as soon as the AI wave hit, suddenly every database and otherwise sprouted vector capabilities. I wouldn't be surprised if Microsoft Excel can be a vector store or something like that. But anyway, it's, if you wanted that checkbox, it's definitely there. That's, it's a nice checkbox. The full text search on the other hand, I had no idea. That is, that's cool. Okay, gemfire.dev. I've added that to my old reading list here. There's actually like quick starts. There's a tutorial. You can learn. You can install stuff. Oh, this is so much better. All these years I've been talking about Gemfire. We never had a website like this. So and this is Broadcom. This is new. This wasn't there before. I'm almost sure of it. This is great.
Yep.
Look at
Yep.
this.
Yep.
Gemfire and Cloud Foundry and Kubernetes, and you can just download it locally. All in one place. You know how much I would have loved all this years ago? I am so impressed.
Oh yeah. I didn't mention that because yeah. So again, another thing that the product team did is like the audience here. You can get started. There are images of Gemfire that are available on Docker. So that in Docker.hub, you don't even need to use a license. You can reference our images to get started. It'll ask you a question. Do you agree to the license terms? It's basically saying you're not going to be using this in production. You're going
Right.
to be doing your local development. It's easy to get started.
Yeah. I can't wait. Okay. We should, if you were free at some point, I know you're like super busy, but if you're feeling more generous, even more, maybe you can come back and show us some of that someday. If you have some time, maybe. Please.
It would be my honor and my privilege.
Oh.
My only I told you this, like I was a little bit nervous because you told me not to call you sir.
Yeah, please don't do that. No, it's okay.
And I call everybody sir. And I was
Yeah,
just
very
like,
kind.
I'm trying to train myself, to retrain myself. But you deserve to
thanks,
be
buddy.
called it, but I'm not going to say that word.
Appreciate you, man. I really do. Okay, that's so cool. So, let's talk. Oh wow, I'm so excited right now. We should have done this last. Gregory, we should have done the Gemfire stuff last because you're, they say save the best for last. Let's talk about RabbitMQ. I love RabbitMQ. I do a lot of demos for Spring integration, Spring Cloud Stream. I do a lot of demos using messaging. I have reached for JMS maybe twice in the last 5 years. I'm not a fan, don't use it, don't like it, don't care for it, don't like. I'll spend time to help people move away from it. It's one of my least favorite things in the world. And then, Kafka's fine, but most of my use cases before the sort of big data thing, 10, 15 years ago, my use cases were messaging, and I just wanted a better message broker. And JMS is, for people who don't know, the Java Message Service. It defines these interfaces for messaging. And I had, I was a fan. My background is in messaging. I love messaging. And back in the early 2000s, Dave Chappell, not the comedian, but the his name is pronounced differently. Not Dave Chappelle, Dave Chappell. He wrote a book for O'Reilly called the Java Message Service on the Java Message Service, JMS. And I still have that book signed by him, right? And it says, "Get the message, Dave Chappell." Yeah. And so I like JMS in theory. 25 plus odd years ago, 20, what year are we? 26. So that book came in like 2000. I don't remember. It's been a long time, but I liked it in theory because the whole point was it was supposed to provide a way for people to consume message brokers. But it did so by undoing the things that were great about message brokers, which is the decoupling. I don't want to, like if you deploy a JMS client and a JMS service and the JMS server changes, you might have to update the jar for the client because they're Java interfaces. There's no protocol there. It's a Java specific thing, right? Imagine having a flag day upgrade for a message broker. I mean, it's bad enough when you have to do it with like a database driver or something, but your message brokers, the whole point is to encourage decoupling. And now I'm coupled by not just the shape of the interface, but the version of it, because they each JMS broker might have its own protocol underneath the hood. So I was like, this is bad. And then JMS has a producer, destination, and consumer. Is that right? Yeah. You have a producer, and it can be either a topic or a queue, and then you have a consumer, right? So the consumer and the producer converge upon one thing, and if that one thing changes, you have to update the code on one of the other sides or both, right? And so it's very coupled, right? And so I was looking for something that gave me the indirection that I want. So if I want to route, let's say I send a message to this thing, I want to move that data to some other swim lane so it does something else, and then deliver it to the consumer that's waiting for it over there. Well, I can't do that with JMS because they're talking to the same thing. They have to, right? So here comes RabbitMQ. It's not a Java API. It's an AMQ. It's the AMQP protocol, right? AMQP 0.9 for the longest time. Is it now 1.0? Is that the default in RabbitMQ?
Yes, we do support 1.0, and other newer features are going to 1.0, but you can still use 0.91. But move towards 1.
Right. So it's a protocol, big fan, created by, I think it was Chase. Might be, I think it's Chase, one of those big banks. Don't sue me if I'm wrong.
No, you're right. You're right.
Okay.
You're right.
You never know. And it was a really, 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 really forward-looking thing. I mean, I feel like we win when we use it because it's such a prescient thing to have. And it also has a different topology. A producer sends a message to an exchange. Exchange can then route it to wherever it wants, including to other nodes for replication, or it can just send it out as like a topic, cascading topic, or it can send it out to a queue, right? It can send it to wherever it wants, but eventually it arrives at a queue. So that exchange acts as like a door into the broker, and then from there you can go left, go right, go straight, go whatever, and then it eventually gets and send it to a queue, and that's where the consumer lives. So the thing to which a producer sends is different from the thing from which a consumer listens. Like you can add whole other hops in between. Just because it arrived on this server doesn't mean that the consumer is going to listen to it on the same server. It could be a totally different one. It might be a different system altogether, just amazing. You can change that. You can have these things talk to each other in the same server, in the same broker today, but then tomorrow you add 5 other systems that get routed to in between the delivery to the consumer, and the consumer and the producer don't need to know. The routing changes just by itself. So huge fan. But big data, right? Here comes big data, and it's not a new thing, right? Obviously, it's 15 odd years or so we've been talking about this, and I think one of the things that sort of becomes interesting in a microservices environment is CQRS, command query responsibility segmentation. This idea that I can replay, or event sourcing, that works well with CQRS, right? event sourcing is this idea I can replay missed events to rebuild the state of the world, you know. Um, and so you need something that looks not like a message queue, but more like a log, right? And so you just mentioned change data capture, same thing. I want this idea of I want to consume the world, you know, and replay the messages to arrive at a consistent state. It's not really possible with JMS or with RabbitMQ in its base form, right? Because those messages are ephemeral. They get delivered and then they're done. Um, so now we've got this thing called RabbitMQ streams. Is that going to help?
Absolutely, absolutely. So yeah, RabbitMQ streams is now. I mean, it's not new anymore. It's
No.
about I forget how long it's been. I think it was introduced in Rabbit version 3.9, and right now we're on the 4.0 series. So it's like as the time of this recording, we're like 4.3, right? So it's been there for a while, and it's exactly what you said. It's an event log. It's an append only consumption. So by default, like the whole message broker use case that you mentioned, where you publish it into an exchange that gets routed to a queue. The consumer consumes that queue, tells RabbitMQ, hey, I got it. And then
Right.
Rabbit says, okay, you got it, I'll remove it. But now with a stream, those messages are not removed. So what happens is, but it does have some tracking, like which consumer consumed which message, but the consumer can always say, okay, only give me the new messages, the ones that I haven't processed, or the consumer can say, give me all of the messages since the beginning of time or since this point in time. So it really opens the door up for Rabbit to be used as another source of truth
Ah,
for auditing. But the main thing it did is, again, the RabbitMQ team, which I always say this, I am such a fan of the RabbitMQ team.
me
They
too.
are rock stars.
Yep.
They did an outstanding job of developing. This is basically a new protocol. It's not AMQP.
Right.
You can use you well. I'm probably jumping ahead of what I wanted to talk about, but you can use AMQP with this streaming protocol. But
Right.
there's a streaming protocol where again it's optimized. So some of the benchmark numbers that we've gotten, like for example, it was like 17 million messages per second for messages that are like almost a kilobyte in size. So because the knock on RabbitMQ, uh, traditional RabbitMQ, was it wasn't able to handle those really high throughput use cases.
Right.
Now it is, Josh, it is knocking it out the park.
Right.
We have some customers that done side by side comparisons with Rabbit and other competing technologies, and they've said that Rabbit has outperformed most of them, right? So now you got, and this is like, you don't have to like stand up like another instance of Rabbit. Now
Right.
this single instance of Rabbit can do those message broker use cases, those queuing use cases, and now it could do the event log use cases, and you could mix and match. So you were talking about like exchanges. Like suppose I want to
Right.
send to an exchange, and then I want to send a copy of that message to a stream, maybe like for auditing purposes, and I'll send another copy to a queue, one queue or multiple queues based on how many microservices that I have. Like I could do all of that now on a single stack. And also now with streams, when you talk about like CQRS and the ability to
Right.
replay messages, now you can replay messages intelligently. So instead of just saying, give me all the messages since this point in time or since the beginning of time, I could say, hey, Rabbit, give me the messages that match this query predicate, right? So, and you can build up like a topology of all attributes, like by customer last name, some customer information, whatever properties you want, and be able to query. And this is a server side query. So, like other competing technologies, when you do like a query, what it'll do is it'll create a copy of that data in another queue or another storage that matches that query. But in Rabbit, these are all server-side queries, so it doesn't copy the data. So it's optimizing your storage and your infrastructure. It
Wow.
just gives them right whatever matches that query condition right to your clients. So you could do it real time, like we talked about Gemfire as a continuous query. So as new messages are coming into the stream,
Right.
there'll be a dynamically match against the query, or when you're replaying messages, you can replay based on matching to a query. So a lot of powerful stuff that's unlocked, and scalability, and still keeping ordering things like that. Yeah, lots of stuff built into streams.
That is super cool. I is there is there in the Kafka world they have something called Kafka Streams. Are you saying I could do something like that? Like Kafka Streams is separate from Kafka. Kafka has a durable replayable log, but Kafka Streams is a programming model where I can do, like we said, filtering on random streams, and the output of one expression goes to the input of another. Is that what
Yeah,
you're
and that's
describing?
that's what Conflict Streams does. And I said I try to like not call out other technology. I try to be
Sure,
I'm non-combative.
sure.
I'm a lover. I'm not a fighter.
Yeah.
But anyway, so yes, it's very similar to Kafka Streams. One thing that Kafka Streams does that Rabbit Streams doesn't do, like this whole notion of windowing and doing aggregations.
Okay.
So you could do like group by and averages and all that stuff in Kafka
Right.
Streams, and they'll take like a window of time and just match it and give you the result of that.
Uh,
That's probably one of the fewer things that the current version of RabbitMQ Streams does today, but it's a similar idea to be able to like dynamically filter the data, but it doesn't
yeah.
do aggregates.
Interesting. Super interesting. I love RabbitMQ. This is the fact that I can do this now without having to, because I don't have, uh, I don't have a use case where it's just one or the other, right? Sometimes I want messaging, sometimes I want replayable, durable logs, um, and the fact that it's in the same thing. Also, multiple protocols. We mentioned AMQP in the beginning, but now you've got Stomp, you've got AMQP, you've got AMQP, two different versions of it. There is actually, I'm not sure, do we still maintain it? I don't know, but do we still have the JMS client compatibility library
Yes,
for
yes,
RabbitMQ?
yes. Yeah, yeah, yeah. Yeah, and that's one of the exciting things about RabbitMQ, how
Right,
you can intermix all of these different protocols all on a
right.
single stack. Uh, all of the programming languages that Rabbit supports, just about every language that you could think about. They probably have a small talk. He was talking about sport. They probably got a small talk client. I
Right.
don't hear anybody using small talk anymore. But
Well,
it's like it's like an insane list of client libraries that are supported
right.
on a Rabbit with the various protocols. So you mentioned AMQP, different versions of AMQP, MQTT.
Oh yeah,
Familiar with
for
that?
embedded
Yeah. Yeah,
IoT.
for like Internet of Things. So a lot of devices they talk MQTT out of the box. You
Yep.
could use RabbitMQ for that. And then again, like for all of those protocols that Rabbit supports, WebSockets, you already mentioned Stomp. Uh, you can use the clients can talk to Rabbit, and then you can use either exchanges and queues and or streams, right?
Yeah.
See, you have universal capabilities across many different protocols for an extremely large number of potential programming languages slash clients.
That's awesome. The you mentioned languages. RabbitMQ is built in Erlang. You mentioned how great the team is. I agree, and the reason I know they're great is because they have been kind and pleasant and responsive to me for as long as I've known them, despite the fact that they have to use Erlang, right? Not a good language. Great runtime, amazing runtime, and that's what you want. You want that runtime when you're building a distributed system like RabbitMQ. Uh,
Yeah. Mhm.
I'm a huge fan of Beam, but not of Erlang, Yeah, good team. Okay, good. I'm glad we had this. So I was checking because you brought up a great point, which is when was it added? And you're right. We had Arnaud Colo, I'm not going to pronounce his last name because I might butcher it. Um, I speak French, and I think he speaks French, but the name is like some sort of wonderful mix between like French and Italian and Portuguese. I don't know how to pronounce it. Um, but he's on the RabbitMQ team. We had him on the show here many years ago, and I was just you saying you don't remember when it was introduced made me remember that I also don't remember, and I should because I actually had him on the show. And so I went to the AI as one does, and it says 3.90 in July of 2021, which makes sense. I remember it was during the virus, right? I remember that interview was during like, social distancing and all that. Okay, well that's cool. Oh my God, how has that feature been received? By the way, I don't know.
Yeah, that's why I want to say I want to thank you for kind of highlighting this topic because unfortunately I still hear a whole bunch of developers and clients that still don't know that Rabbit has this feature. They're like,
What?
wow, like you know what? Um, Rabbit is it's one of those rare products that I support where pretty much people just leave it alone and it just
Yep,
works. I
it
mean, it
works.
just it just does what it's supposed to do, and
Yep,
they never introduce new feature. They never research new features because it just does it. Um, like most people, like Josh, a lot of people didn't even know that you have an exchange because in Rabbit you can actually like you can you can specify the producer can specify a queue.
right.
So under the scenes it is using exchange, but then there was some customers that have been using Rabbit for years. Like they didn't know that there was an
Really?
exchange. Yeah, because that's why I say like most of the customers are probably using like 30% of the capabilities of RabbitMQ. So long story short, we're still trying to get the word out.
Oh,
We're still trying to
it's such
get
a
the
good
word
way.
out of how awesome this is. We're still trying to get people to do a comparison. You think Kafka or Pulsar is better? And you think it's for better for performance? Try it out. Do it
Yeah,
side by side. We're daring people to do it. And the people that are biting, they're saying, oh, wow, this is like outperforming this. I had an impression that it couldn't do this. Now we're trying to unlearn things. We're trying to drive new perspectives on this.
right.
So anyway, it's a work in progress.
Well, it's an amazing work, and that's the thing. It's been a work in progress for since 2007, so it's actually very mature, very, very entrenched, very, very, very good. And like I said, it was built at banks, not like some, you know, Silicon Valley, uh, you know, 20% project or something like that. It was actually built by people who have a lot of money on the line, and they need the best of the best and the most secure of the secure. So I'm a huge fan. What's the RabbitMQ streams is, as you mentioned, we've established it's half a decade old at this point. What's the latest and greatest? What are features people should be looking at in RabbitMQ in the last few years? Anything worth?
Yeah, yeah. Oh, I'm sorry.
No,
So
no.
a lot of this is all of the newer feature that are building into streams, but
Right,
also they're starting to build a lot of connectors
right.
into a RabbitMQ. So, for example, recently there was. Are you familiar with Apache Spark?
Yeah, yeah. Oh wow.
Yeah. So now there's an Apache Spark slash RabbitMQ streams
What?
connector.
So is that
They
is that so
are
that I can consume RabbitMQ streams from Spark, or so that I can send to Spark from RabbitMQ streams?
consuming streams data from
Ah,
Spark, like combining the idea of the SQL filter and things like that, and
right,
doing in-stream analytics on data that comes in real time, things like that. That's what they're doing, and they're adding a lot of like non-functional stuff, is making it more
right,
robust. The ability to have like disaster recovery. So, for example, let's suppose if you have a RabbitMQ cluster in one site and you want to do like a wide area network replication of not only the topology information, but actually the messages themselves. So that when
right.
you fail over, the messages that you processed already, you don't have to reprocess them. It just knows that you've already processed them when you fail over. Things like that that they're
That's
building into the product.
that's quorum queues. isn't it?
Yes.
It's the
Well, it's
raft
quorum
stuff.
queues within one cluster, but then
Right.
when you replicate all of that, whether it's a quorum, whether it's a classic, the fact that 50 out of 100 messages have been processed, right? That's actually using streams under the
Right.
covers to replicate that information across in another data center, like for example, running in EMEA. So that when you
Right.
fail over to EMEA, say, again, all of that, not only the topology information, but all of the 50 records that you have not processed, they're ready to go, so the consumer can pretty much pick up where they left off.
Oh, I'm such a fan. They have, I know one of the new things is a raft, consensus support. So much smarter sort of handling of split brain scenarios, that kind of thing. That's really cool.
Yep. Yep.
Because it's using Erlang, it takes like no memory at all to run it. Uh, People use it in embedded situations, which is like you just said, you can for IoT even, it's just so tiny. An idle RabbitMQ cluster is basically non-existent in terms of footprint. Um, just such a good piece of tech. Okay, I'm a big fan. What else? We mentioned Valky. We talked about Gemfire. My sweet Gemfire. And then we talked about RabbitMQ. My sweet, sweet RabbitMQ. What else has what's new in the data world, my friend?
Have you used Spring? I think you said you mentioned Spring Cloud Data Flow. Have you
Yes.
used
Oh
it?
yeah.
Yeah,
Of course.
yeah. Okay. So, for those who use that, we have a commercial version of that product, which is Tanzu Data Flow. It's pretty much the same product,
Right.
but it's kind of rebranded. So all of this like low code data integration, where you
Right.
have this library of connectors that either read data from a source system or do some processing in between before they write it to a source system, and whether it's like a relational database or it's a NoSQL database, so on and so forth, right? Instead of writing code yourself, you kind of have like this really easy to use UI to build these pipelines dynamically.
Right.
That's another thing that I kind of getting more and more involved with, especially in this AI and agentic world. Like, so as people are talking about agentic workflows and things like that,
Right.
applications communicating with each other. When they communicate with these agentic applications, for example, maybe they need to have consensus
Right.
on the output of something, right? So they might use different models and things like that. Like the communication between those apps can be RabbitMQ, or it can be a messaging solution. But the orchestration of these apps, the deploying of these apps, is something that you could do with Dataflow. So, for example, you can register any app that you build, right? That's that's a source app, or it does some processing, or it's like a
Right.
sync app that writes to a database. You just register with Dataflow, and then you don't have to, if you're deploying these environments in a containerized solution like Kubernetes or like Cloud Foundry, which we support something called Tanzu platform. Again, you don't have to worry about like building like all of the YAML associated with that. For example, on Kubernetes, you
Right.
just say, hey, platform, push this solution where this app talks to this app and talks to this app, and here's all of the configuration details I need to provide to this app. You're letting the platform that's really it's handling the data orchestration or the application orchestration for you. That's another, I think, really exciting thing that I
Super
would like
exciting.
to deepen.
Data flow is one of those things where um, I come from the messaging world, and yeah, we just talked about Spring integration and all that, and one of the most painful parts of building something sophisticated or useful is I've got now an incredibly distributed system, and that's the way it should be because I want to, I don't know if it's still talked about. We used to talk about staged event-driven architectures, right? The idea that I'm going to put data into a pipeline, it'll go to a processor, that processor will deal with it and then put the data back into a pipe. But as it's going through each of these stages, it's buffered, and so you don't overwhelm the downstream stages because even because things are they move only when they're ready, and so you have the ability to scale up capacity by updating each of these different pipes, and it creates a more robust system because it's not everything all at once for every interaction. It's just a bunch of small discrete components, and they all have a queue to absorb extra command capacity rather. So if I'm a processor and I'm only handling 5 messages per second, but the downstream thing can handle, let's say I'm handling 5,000 requests per second, but the downstream processor can only handle 1,000 per second, right? I can either spin up a second instance of that downstream processor, right, or maybe 3 or whatever. But in the meantime, it's not going to get overwhelmed because there's a buffer, there's a broker, there's a queue in the middle. So that's what you want to do in a good data pipeline, is to move things in a way that it doesn't. At no point does any processor run the risk of being overwhelmed. But how? It's so much work to write all that code, to set up the right handoffs and the broker and all this stuff. Data flow is it's literally a pipes and filters definition, isn't it? Just
Yeah, yeah, absolutely. And we were talking offline about, like, in the Spring community, the
yeah,
projects that make it super easy to implement these data patterns, like Spring Cloud data, Spring Cloud Streams, I should say. So
yeah,
Spring Cloud Streams, you're just defining. You don't even need to know that you're using a broker at all, right? It abstracts the way you don't
right,
see any reference to a RabbitMQ library, for example.
right,
You're just implementing, for example, Java functions. So, for example, in the Java world, there's like supplier interface, and that supplier interface, it has a get method. That get method accepts no arguments. It just returns something. So if you wanted to build an application that maybe reads data from your source system and just returns output, and that output is sent to a broker, all you gotta do is implement a get method. And if you want
yeah,
to implement a processor, you implement a Java function which has an argument and returns out something, right? And
right,
then if you wanted to implement like the final output of a data pipeline, you just implement a consumer interface in Java just has the accept method. It passes in an argument, and then all of the buffering. Let's suppose like you're keep with the idea of the sync, right? You're trying to save this into some relational database, and maybe that relational database can only handle what, like 100 transactions per second, 1,000 transactions per second, right? But you got
yeah,
millions of transactions coming per second into your system, right? So the idea here is you use a messaging solution, like, and we talked about like RabbitMQ streams can handle like 17 million messages per second. That's a problem that most customers, they will
it's a
most of them
dream.
will
Come
never
on.
get to like 17 million messages per second. So the
Yeah,
point is, like, you don't have to worry about like these spikes that happen when you're using the message layer as an intermediate layer. So if you don't overwhelm your database, you can use Rabbit as a buffering layer. You can have that data ingested at really high volume and keep the data, and then process the data as fast as possible, that you don't overwhelm your downstream databases.
oh, so good. And of course, if there is, this is where it all comes together. If there is a risk, like if your problem is you need to stage a lot of data, I imagine there's even some use cases for RabbitMQ and Gemfire, right? I could do processing RabbitMQ and then just stash it in the RAM cloud, and then slowly these slower. I love Postgres, but let's be real. It'll never. I can never write to Postgres as fast as I can write to Gemfire. Not even close, right? I love Rabbit. I love Postgres. Don't get me wrong, but just physics, right? That's just RAM is always going to be faster than disk. Um, so I could just stash data there too. Wow, so good. Um, my friend, this has been a quick tour. I can't believe we're already. I'm sorry. It's my fault we started so late, but we've already gotten to a point where I need to like. We need to wind down here a little bit because I know you've got to go, and I have another live stream in theory in like 10 minutes. Um, sir, where do we find you on the internet? Well, first of all, are you on the internet? Do you want to be found? And if so, where can people find you? That's the question.
Yes, I am on the internet. I would love to be found. Probably the best way to connect with me is on LinkedIn. So you could just look me up on LinkedIn, and yeah, I would love to connect. And
Great.
again, thank you so much, Josh. I just gotta say, I am such a huge fan of you. You
Oh, thanks,
are
buddy.
an amazing person, and just thank you for the invite, sir.
Thank you. What is the I'm gonna put your here we go. I've got your LinkedIn. Let me just put that here before we sign off. StreamYard, do your thing. I want people to find you and ask questions. And is this I hope I'm about to spam the right person. Is this you? We're first connections on LinkedIn, so I think we're is that right? I hope it's right. Please be
That looks
right.
right. That looks right.
All right. Thank you. Thank you. Thank you, everybody. Thank you, Gregory. Appreciate you. And also if you please send my regards to the various teams doing all this cool stuff you just talked about. Legendary. Thank you.
Have a blessed one, everyone. Bye.
Bye.